We can use sophisticated words or we can use simple words. I am sure the EOC is going to use sophisticated words. So if a point is equidistant from two objects, if it is what? The, Leslie? Same distance from each object. Equidistant. Same distance from each object. All right, so we did a guided investigation yesterday, and this is called the perpendicular bisector theorem. Remember, we folded the perpendicular bisector. We put all sorts of points on that. We folded it and saw that the segments that joined those were congruent, that the segment from here to here was equal to the segment from here to here. That was on yesterday's petty paper. Do you remember that? Okay, so this theorem says if a point is on the perpendicular bisector of a segment, and now we're going to use our new sophisticated word, then it is equidistant from the endpoints of the segment. Equidistant meaning the distance from D to A is the same as C to D. But to use this, you have to know that you have a perpendicular bisector. If you don't know it's a perpendicular bisector, then you can't conclude. Carlin, you want to take notes? So let's do a brief summary. Now, this course is like science or history. You have to study, unlike the way you did in algebra where you just memorized a pattern. You've got to know this kind of stuff. And if you wait till the night before to try to remember all these definitions and theorems, it's going to be a little bit tough. You need to do it as we go. If you're given a perpendicular bisector of a segment, what do you know? Right angles are formed. That's the perpendicular part, talked about yesterday. The bisect part means segment is cut into two equal segments. And this perpendicular bisector theorem says that any point on the perpendicular, this is why we have all these symbols, that's perpendicular bisector, is equidistant. That means same distance from the endpoints. And I think I'm going to start to become predictable. So that means that I could give you algebra based on this segment and the fact that it's been bisected. I could give you algebra based on this right angle relationship, but then you've got to know that a right angle is 90. Then I could give you algebra based on these two distances. And it is these relationships that allow us to write the equations for the algebra. Now, just because the segments are not drawn, sorry about that, those are supposed to be solid segments. If I tell you that this is a perpendicular bisector, and I tell you that this is W, and this is A, and this is Y, I could ask you what is the relationship with segment WA and YA. You see they're not drawn, but what is the relationship if you know that this segment right here is a perpendicular bisector? Brittany? Right, they're equal to each other. So now let's do some algebra. DB is the perpendicular bisector of AC. All right, so now look, is DA drawn in? No. Is DC drawn in? No. However, what do we know about this length and that length? So the equation we would write is 8x plus 9 is equal to x plus 37. So you see, every theorem, every postulate, every definition that we have, you're given basically to be able to use. But if you have not put to memory those relationships, will you be able to write an equation? No. So if we solve, we're going to subtract x. So you're going to have 7x plus 9 equals 37. You're going to subtract 9. So you're going to have 7x equals 28. You're going to divide by 7, so x is equal to 4. So now I want you to try this one. And this might pop up. So the converse means we flip it. If a point is equidistant, and the difference is what we're given. So now all we know, what this means is we know that this segment equals that segment. We know that G is equidistant from the endpoints of the segment. So our conclusion is, then this point G, then it meaning G, is on the perpendicular bisector of the segment. So right now, with the picture drawn, you do not know if you have right angles. You do not know if DE equals EF. All we know is that the distance from G to D and the distance from G to F are congruent. If we know that, then we can conclude that we have a perpendicular bisector. And the fact that it is a perpendicular bisector tells us now what about this angle? What do we know about that angle? Devin? Okay, we know these two segments are equal. So we conclude, therefore, this GE is a perpendicular bisector. And it's all about what you know. They form right angles. That means there's a right angle here. And what do we know, Kayla, about DE and FE? If it's a perpendicular bisector. Right, the bisect means equal, that this segment is equal to that segment. So you see here we concluded this information because we were given that one. If we go back to this page, we were told all of, let me move it up a minute. We were told all of the marked information, and what we did is we concluded that this was equal to this. That was our conclusion. Do you see the difference? Here we're given this information, and now we know this. Over here, we're given that these two segments are equal. Now we can conclude all of that. So with that being said, let me look at the next slide. Have your homework ready so we can go over that. Then it's a major construction day. And all of these constructions are going to be part of the first part of your project. All right, so if I look to the next slide, if I tell you G is equidistant from D and F, meaning this is congruent to this, before we go any further, what can you conclude about these two lines, Eric? If you know this segment equals this segment, what can you conclude about those two lines? This is what we're given. What do we know about this angle? Okay, it's not an angle bisector, but a GE does what to this segment? So, if we know a point is equidistant from the endpoints of a segment, then G is on the what? What kind of bisector? What does that symbol mean? We talked about that. Actually, you were supposed to go on your notes yesterday online and finish the notes. What does that mean? Perpendicular. So you need to make a notation in your notes. So what kind of segment is GE? Exactly. So if it's a perpendicular bisector, that means that it has bisected this segment and it has made right angles. So this sentence right here tells me perpendicular bisector, and then perpendicular bisector tells me right angles and two congruent segments. So what do we know about DE? And so if DE is 6x minus 11 and DF is 14x minus 33, what do we know about EF, Becky? Excellent. It's 6x minus 11. So, Samantha, what equation can we write? Okay, so Samantha has chosen to double 6x minus 11 rather than add it to itself. Those are two different ways to do it. And I'm not going to solve the equation, but that's how we would work with it. Now again, if G is equidistant from D and F, what's the relationship of measure angle GEF? What kind of angle is it? What kind of angle is it, Jeff? It's a right angle. Jeff, what do we know about right angles? So right angles equal 90 degrees. That is exactly how you're going to write your equation. You'll say 4x minus 2 equals 90. So what questions did you have on your homework? Which I think was what, section 5.2? Yes, no? I think it was. Caitlin. 4? Vocabulary? Okay, it says draw a line and a point not on the line. Draw a segment that represents the distance from the point to the line. All right. So if we have a point, here's our line. Well, it's dotted. Here is our point. Now, I could draw lots of lines, couldn't I? I could draw this line. I could draw this line. I could draw this line. All right. The question is, which one of these is going to be called the distance from the point to the line? It will always be the perpendicular relationship. So this line is not good. This line is not good. When we look at the point, from a point to a line, we're looking at the shortest distance, and that will always be the perpendicular. What, Leslie, you had your hand up. Number 10 said, is St. Vincent's Hospital, what does equidistant mean? Same distance. So is St. Vincent's Hospital, where's St. Vincent? All right, is it the same distance from Village Kids Nursery and Legacy School? How do you know? So do you need to see it? Okay, they said, is St. Vincent's Hospital equidistant from Village Kids Nursery and Legacy School? Is this equidistant? So we're looking at, I shouldn't do this, we're looking at this distance and we're looking at that distance. Equidistant means what? Same. Are those the same? No. All right, the distance from St. Vincent's to nursery is smaller than St. Vincent's to Legacy. Okay, what other questions do you have? Hope? Number 22. Number 22 said, if R is on the perpendicular bisector of TZ. One of the most important things you do is to take what they say and draw a picture. What do they say? Picture's worth 1,000 words? So if we take, I should leave the book up there. So we want to draw a segment TZ. So if you did not do 22, draw a segment TZ on your paper right now. Okay? So let me get more space. So we should draw a segment TZ. So you're going to label it T. You're going to label it Z. And then what did it say? It said R is on the perpendicular bisector. So that means you have to draw a perpendicular bisector. How do I mark this perpendicular bisector? Hope, how do I mark a perpendicular bisector? Perpendicular means? The bisect piece means equidistant, so those segments are equal. And what does the perpendicular lines do? Form what kind of angles? Who can help Hope? Right angles. So this is going to be 90. So they told us R. R is on the perpendicular bisector. If R is on the perpendicular bisector, the question is, then R is what? What's the key word from T and Z? Equidistant is our new word. So that's the first part. And then they have this thing, blank equals blank. What is going to equal what? Mim J, what's going to equal what? T R is equal to ZR. Correct. TR equals ZR. Next. Oh, okay. Samantha. 42. Short response. The line y equals 7 is the perpendicular bisector of endpoints A are 210 and B 2K. What is the value of K? So that means midpoint. You would need midpoint formula. So we didn't do that, so I want you to scratch 42. Okay? Put down there, scratched. So I'll remember. There's more hands. Karen. 1 and 2 are complementary. Now, what does complementary mean? This was one of your quiz questions. What equals 90? Two angles. Two angles add to 90. So if 1 and 2 are complementary, that means angle 1 plus angle 2 equals 90, correct? So if we look, this is 44. It says angle 1 and 3 are supplementary. So what does supplementary mean? Two angles what? Add to 180. So what did they say were supplementary? 1 and 3. So we know angle 1 plus angle 3 equals 180. And the question is, what is the measure? Oh, angle 2 equals 30. If angle 2 equals 30, then we know the measure of angle 1 plus 30 equals 90. How do we get measure of angle 1? 90 minus 30 is 60. So if angle 1 is 60, 60 plus the measure of angle 3 equals 180. What's the measure of angle 3? 180 minus 60, which is 120. Brittany, you had a question. 15. 15 said, find the measure of KHL and FHL. So when we look at that, what's the relationship between those two angles? Those two angles were Equal. So on number 15, you've got 6y is equal to 4y plus 18. So we subtract 4y, y is equal to 9. And I don't know what they asked for. Oh, they want the measure of the angles. So if y is 9, then the measure of angle KHL is going to be 6y, or 6 times 9, or 54. And then what does the other one have to be? 54. All right, so I'm going to ask you to leave your homework here on the desk when you leave. And what I need you to do is get out your compasses and straight edge. Okay, so what you all are going to do is you all are going to get a floor plan. This is part of your, yes. And what you're going to do you see your everybody has a garage. So what you're going to have to do is you're going to have to construct your driveway. Then you're going to construct your street perpendicular to your driveway. You're going to construct your sidewalk. Isn't that awesome? So the constructions that we're going to be doing right now are going to be key pieces in this project. So we're going to look at several different perpendicular constructions. So here we go. We're going to go to this page. And no, we're not. We're going to go to this page. All right, we're going to do perpendicular bisector of a segment. So up here, I've got step-by-step directions to do that. So if you get lost, you go online and you find those and you follow those. In the meantime, I've also given you a website that you can watch it also. But we're going to do this. So when you do a perpendicular bisector of a segment, you've got this endpoint and you've got this endpoint. You see those two endpoints? So you're going to take your compass. You're going to put your compass point on one endpoint of the segment. Can you do that for me? Draw a segment. Put your compass point on one endpoint of that segment. Pardon? It should say A13. Oh, but I changed A13. Instead of whatever it says, which is a bunch of bookwork, I've written a worksheet, parallel and perpendicular construction worksheet. And I will let you know which problems of that I'm going to require you to do tonight, because I will not get through all these constructions. All right, so everybody has their compass point on the left endpoint. You need to open your compass so it is over halfway. It's got to be over halfway. Okay, everybody there? So now what you're going to do is you're going to make a nice large arc on the top and the bottom. It's got to go over the halfway point. You're good. Now, this compass point is now going to go to the other endpoint. Now you got to flip your compass. So what you've got to do is you cannot mess with the opening of your compass. It must be the same as it was. This first arc, you have to open it over half. The second arc, you cannot change it. It must stay the same. And so what you're going to do is you're going to make another arc. And the goal is to intersect the arc you just made. And then you take a straight edge and you connect the intersection of those two arcs. And that is a perpendicular bisector. Now, you have to mark it. So you've got to mark the perpendicular, and you've got to mark that the segments are congruent. All right? So now, I want you to do it again. I want you to draw segment RW, make sure you label the R at the endpoints, and I want you to construct the perpendicular bisector of RW. The segment's called RW. The perpendicular bisector, that's what we just did. What do you mean? Oh, I didn't give you one. You can make one up if you want. But the segment that you're bisecting is RW. Is we're going to construct a perpendicular to a line through a point. You have two options. The point could be on the line or the point could be not on the line. All right? So we're going to do this one first. So you're going to take your compass point and you've got to put your compass point on the point that you have. So draw a segment with a point P. Okay, put your compass point on P, and I don't care what. Open your compass. Don't. If I were to open it this large, am I going to intersect my segment? Okay, so I've got to open my compass to make sure that I can fit it on both sides of P. Okay. So now what you're going to do is we're going to come up here, and we're going to draw an arc. So make sure that it goes all the way over P. Now, don't change the opening. The purpose here actually is to intersect this segment. We didn't need that part of it. Oh, look at that, it won't erase. What we need is this point right here. That's going to be one important point. And then leaving this opening, you're going to turn your compass and you're going to make an arc over there. So you make a second point on your segment. So you put your compass point on the point and you intersect your segment on each side of P. Okay, but you got to extend your segment. All right, so now what you're going to do is you're going to move your compass point to one endpoint, or one point of intersection. I'm going to open up my compass more. And what we want to do is now we want to go a little bit more. So now what we want to do is we want to draw an arc up here. And this arc should be on both sides of P. So we started here, we made two arcs. We put our compass point on the right endpoint, and now we're going to put our compass point on the left endpoint. And the goal there is to intersect the arc you just drew. So now when you connect, you're going to connect P with this point of intersection. Now this is not a bisector. What we do know about this is that this line is perpendicular to the other line at P. All right, hold on. On your worksheet, what I want you to do the only problems that you're ready to do on your worksheet are problems 1, 2, 3, 9, 10, 11. Okay? So on this worksheet, all you can do are problems 1 through 3 and 9 through 11. And again, A13 from what's written on your syllabus is totally changed. It's that worksheet. And that's all you're responsible for is this worksheet, those 6 problems.